Record. All right, cool. So I think we're up and running, hopefully. Let's start a new little note here. Oh, that's no bueno. There we go. A little bit better. Yeah. Change this. Stat 121. Yikes, September 19th already? Crazy. So, you got your assignment, right? Oh, did anyone not get an assignment or a formula sheet? And then one for you. So I want your assignment handed in on the paper that I had printed for you, okay? This is just, I haven't done this before. Usually I just get you to write on paper, but for some reason people like to hand in really messy stuff. So this should just be easier for me to read and mark. So just do all your work on here, right? Remember to put your full name on there, your student number. I don't know all your names yet, right? So I have to find you when I'm putting in your grades. So you got to help me out there, okay? For assignments, right, those due dates that I have on the term sheet, I'll try to get caught up again, right, for assignment 2, so it's on track. But in general, I'll always give you a week to work on them, right? So unless it's just I make a quick assignment, right, then maybe not as much. What's going on here? But okay. So you have a week to do it. It is due. Beginning of class, 8 a.m. next Wednesday. I might not notice. What if you're not going to be here on Wednesday? Oh, come on. You can scan it, email it. You could even, here's a wild thought, hand it in early. That's an idea that I like. Okay, so whatever you do, and you have ways of getting this to me on time, you got to do it, okay? So plenty of time to do it, plenty of time to put it off for. Okay. So any questions before we get started here? So we are going to talk about some of the stuff that we're doing on the assignment today, right? And that's why I didn't want to get it to earlier. There's a reason. Okay. So last day, we started talking about numerical measures of center and spread. Okay. And so just as a little review, not too much, because it was just on Monday, right? And so just as a quick review, we said that, so for numerical measures of center and spread, we said that we're going to talk about, the center for a normal distribution and a non-normal distribution. Okay. And then the spread. So for a normal distribution, we talked about the mean, right? The mean is the average. And then we calculated the standard deviation together, right? And it was a big, long calculation. And in fact, I do get you to do it again. Very last question, last page, right? Find the standard deviation. Okay. So standard deviation. Today, we're going to talk about the center for a non-normal, in fact, any distribution, but we'll only use it for non-normal distributions. We call it the median. Okay. And if we have a non-normal distribution or a small sample size, right, this is what we'll be dealing with here on the assignment and on the test, then we're going to use the interquartile range, IQR, right? The interquartile range is the IQR, okay, as our measure of spread. Okay. So let's talk about the median. Okay. So the median, we talked about it last day briefly, right? Because, well, not really. We talked about the average isn't necessarily the best measure of center for all distributions, right? When we're talking things like income or really anything to do with money, right? There's going to be, pardon?
Any non-normal distribution.
Exactly, right? So then we shouldn't be using the average if we have a non-normal distribution, right? So if it's skewed in any direction. So that's when we should be reporting the median, right? The median is where we sort all our data, right, from smallest to largest, or largest to smallest if you want, right? So you sort them all, and then you find the central value. The central value is the median. Okay. So, okay. The median is the value that splits your data in half. Is the value that splits your data in half. I don't know, all my sounds are off on here, so not sure what that ocean sound is, but hey. I think someone's at home enjoying their tunes. So splitting your data in half, meaning your smallest 50% is below it and the highest 50% is above it, right? So the smallest 50% of data is below this point. And the largest, same thing, the largest 50% of your data, data is above this point. So to find the median, there's all kinds of fancy formulas that we could use to find the location of the median. I don't use those. I use my, my patent pending boop, boop, boop method. So what I do is I sort my data. Remember, we're only going to do this by hand for small data sets, right? Looking at your assignment, we're looking at maybe 9 or 10 data points, right? So you're only going to have to do it for small data sets, right? And so what I do is I sort them, and then I take my fingers on either end, right? Starting at the smallest and the largest, and then I boop, boop, boop my way in, okay? So that's what we're gonna do. We're gonna use the boop, boop, boop method, okay? So to find the median, your first step, and this is a very important step, right? And I do have to take quite a few marks off if you forget to do it on the assignment or on the test, because it's kind of fundamental to the idea of the median being the central point. Well, it's only central if you've sorted your data already, right? So just doing it for the data as it's listed, it doesn't do anything, right? That's not the median. So the first step, and you have to remember this, is to sort your data from smallest to largest. Doesn't matter if you want to go largest to smallest, you can. I don't think that we like to do that intuitively. We like to go from smallest to largest. Okay. And then step 2, right? You're going to sort your data, which means you're going to rewrite your list out. Double check that you have the right number of data points, right? So you're not missing one. So make sure you've included all the data points. Okay. And then use the boop, boop, boop method to find the central value. Use the boop, boop, and we have to spell it out. Boop method to find the central value. So we were working on an example, but I found this cute example from my old notes. So the number of babies in a litter from 11 mice are recorded below. That's cute, right? So let's use that one. Okay. So as an example, the number of babies, or the number of young, I guess, in a litter from 11 mice. Okay. The number of babies in a litter of 11 mice? There's 11 mice, each had a litter. And so the number of babies in, and then now I'm struggling with the number of babies in a litter from 11 mice are recorded below. The number of babies in, how about we say each litter from 11 mice are recorded below. As long as you get the idea. Okay. So you had 11 mice. Each of them had a litter of babies, and then you're writing down how many babies there were in each litter. Okay. So the first mouse had 9. And then the second mouse had 7, and then 5, 9, 8, 6, 6, 5, 1, 10, and a whopper 16. Okay. So that's your data set, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points, right? So now if we're going to find the median, first step is to sort these guys, right? And so just scanning here, oh, I have 1, 1. Okay. And I like to just kind of maybe put a check mark underneath, or I don't know, cross it out, or just to indicate to myself that I've already done that one. Okay. And then scanning here, I see 2 5s. So 5, 5, done, done. And then 6 and 6, done, done. 1 7, just 1 8, I think. 2 9s, 1, 2, then 10 and 16. So just double check. 1 2 3 4 5 6 7 8 9 10 11. Phew. I just wrote them a little more squished, I guess. Okay. So now we're gonna take try the boop boop boop. So you're gonna try it. You're gonna take your fingers starting on either end, and then boop, 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 boop. So 7 is our median. Yeah. Then we take the average of them, and I'll show what to do there. Right, but for now, the median is just 7. Okay. So say we only had 10 data points. Hello? Right, so I'm gonna do all these guys, but copy. Okay. And then I'm gonna erase this one. And let's ditch the 16. Just remove the 16. So we've got 1 5 5 6 6 7 8 9 9 10. Okay. So now when you start at either end and you boop your way in, you boop, 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 boop. Try not to go cross-eyed. What we do is we circle both of those numbers that we land on. And then to show that we're taking the average of these two, which is what we have to do, okay, just as a fact, we draw a line down the center, and that line is where the median is. Okay. So the median isn't one of the numbers anymore. It's just going to be, so the median, we write 6 plus 7 divided by 2, right? Taking the average of them. That gets confusing, right? We're talking about the median. Hey, how'd the mean get in here? But it's just what we do. So 6.5. So those are the two scenarios, right? Either you land on the number, or you land on two numbers at the same time, and then you have to take the average of those two, right? And you show it by drawing a circle around them and drawing a line down the center. Okay. So, any questions about that? Yeah. All data. Yeah.
If we have like a normal distribution and we use this, we don't use marks. If we just prefer to use this.
There's going to be scenarios where we have to use the mean, right? But no, I can't dock you marks because if we have a normal distribution, okay, then the mean and the median will be the same. So, or roughly the same. Okay. So, if we have a normal distribution, the mean and the median will be roughly the same. We use the median for non-normal distributions because the median is resistant to outliers. We haven't really talked about outliers, but I think we all kind of have an idea, right? An outlier is just an extreme value, right? Some rare occurrence, okay? And so we use the median because it's resistant to outliers, whereas the mean gets pulled towards outliers, right? The mean gets pulled towards extreme values, okay? So we use the median for non-normal distributions because it is resistant to outliers. Okay. Whereas the mean is not resistant to outliers. Whereas the mean is not resistant to outliers and is pulled towards the extreme values. So it's not really a good measure of center anymore, right? If it's being pulled towards those rare extreme values, then that's not that good. So just kind of visualizing it, right? We have, if you have a distribution that's skewed to the right, because it's skewed in the direction of the tail. Okay. Skewed right. Okay. The median would be somewhere kind of reasonably where we would think the center is, right? Oh, that's not what I meant to say. Not the center, but the median. Whereas the mean would get pulled towards the tail. Yes. So outliers are just rare extreme values. And so when we get this kind of tail tapering off, that's really just indicating that there's very, very few data points out there, but they're out there, right? And so that's how we see, okay, we have some outliers there. And so, but, right, if everything's kind of even Steven here, and we have a normal distribution, then the median is in the center, right? Cutting the data in half, and the mean is also in the center. So that's how you know. So you can look at the median and the mean, and then you'll know if it's roughly normal, right? Roughly symmetric, if they're approximately the same, right? Or if the mean is larger than the median, then you have this right skew, right? Or if the tail is going to the left, right? Where we have some left skew. The median is in the center roughly, and the mean, right? The mean is just pulled towards those extreme values. Cool. So, any questions about that? No? All right. Let's talk about the interquartile range, right? We said the interquartile range is going to be our spread, our measure of spread for a non-normal distribution, or any distribution, really. Okay. So the interquartile range, or IQR, the interquartile range, IQR, is the distance between the first and the third quartile. First, we have to talk about how we find the quartiles, okay? But just as a fact, the interquartile range is the distance between the first and the third quartile. So thinking about how we found the median, right? The median splits the data in half, right? So then we have 2/4 on one side, 2/4 on the other side, right? So we can do the same thing, right? With the lower end, we can find the median of the lower end, and that's going to be your first quartile, right? So now you're splitting it into quarters, your data into quarters, right? So then you have your first quartile, your median is technically your second quartile, right? And then you have your third quartile doing the same thing. You can boop, boop, boop your way in, and then you have your whole data set, right? Your fourth quartile. 4/4 is your whole data set. Okay, so I'll just grab this first one that we did with all 11 data points. Oops, paste. I didn't mean it. There. And phew. Okay. So we have 1, 5, 5, 6, 6, 7, 8, 9, 9, 10, 16. Okay. So to find the first quartile, okay, you do the exact same thing, but now the first quartile is somewhere in here, right? If you had to chop this up into quarters, you would say, okay, I'd chop here, here, and here somewhere, right? And then you'd have 1/4, 2/4, 3/4, 4/4, right? So we're gonna do the same thing, but now we're gonna zone in on this lower end, right? And we're gonna find the center of this lower end to find the first quartile. Okay? One thing to keep in mind is that we've used this 7 as the median, so we can't use it anymore. So we start our boop, boop, boop at the 6. So we start here, and so we boop from the 1 and the 6, so boop, boop, boop. So our 5, right, going from boop, boop here, oops. That's your first quartile, okay? And we denote it by Q, capital Q subscript 1. Q1 is the first quartile. Oops. First quartile, right? 7 was the median, right? And then to find the third quartile, exact same thing, but we've used that 7, so we can't use it again, right? And so we start at 8 and 16 and boop our way in. And our third quartile, same idea, Q subscript 3 is the third quartile. Is your 9. Okay. Okay. So here, I'll just make a note. Since we use this value as our median, we can't use it to find the quartiles. So we start our boops on either side of it. So we start our boops on either side of it. Right, depending on which side you want to work with. Okay, so what happens in that other example where we had the median is the average of two values, right? This one here, just stealing this example, I'll do this whole thing. Copy. Okay. So here, right, we didn't actually use the 6 or the 7 as the median, right? We use them to find the median, but the median, remember, is at that line that we drew, right? And so now the difference is that we start, so we can't be on the line, but that's okay, we wouldn't want to, right? But we start our boops at the second 6 to find the quartile, right? The first quartile. So now we boop, boop in, so boop, boop, boop. Q1 is 5.
So we start from the 6 that's within the circle?
That's right. Oh, okay. Because the median is at the line now, right? So we haven't used either of those 6 or the 7 as the median. So we include them in our quartiles. And same thing on the other end, right? We start at the 7 and the 10 and boop our way in. So Q3 is 9. Okay. So I'll just make a note here. Since we didn't use either of the 6 or 7 as the median, we include them when finding the quartiles. So we said that the interquartile range, right, is the distance between the first quartile and the third quartile. And I give it to you on your formula sheet, right? It's the last one in chapter 1. The interquartile range is Q3 minus Q1. Okay. So the interquartile range is Q3 minus Q1, right? The distance between the first and the third quartiles. Okay. So for this first example with all 11 data points, right, our Q1 I'll just fill it in here, was 5, and our Q3 was 9. So regardless of these, right, we find that we have the same first quartile and the same third quartile. It's just, it's important how we find these because that's not necessarily always going to be the same, right? So here, it's nice because the interquartile range will be the same for each of these, right? The distance between 5 and 9 is 4, right? If I asked you that, you would just say, oh, it's 4, right? Or you can use the formula, right? So for each of the two, or for both of the examples, rather, for both of the examples, Q1 was 5 and Q3 was 9. So they'll have the same interquartile range. Okay. Just slightly different medians, right? But, so the interquartile range is Q3 minus Q1, which is going to be 9 minus 5, which is 4. Okay. Cool. Make sure I didn't skip anything here. Blah, blah, blah. Here. Okay. So that's your interquartile range, right? So I could ask you for the interquartile range, or usually what we do is if you flip through the assignment, right, I'll ask you for a 5-number summary, right? And so a 5-number summary it's just a list of these 5 numbers. So I like to start at the minimum and move my way to the maximum. Okay. So it's going to be the minimum, Q1, the median, Q3, and the maximum. Right. And we saw this in the lab too, right? In that summary command. Right, it basically had the 5-number summary with the mean thrown in there in the middle of things, right? But it had the minimum, the maximum, first quartile, third quartile, the median, the mean, right? And so this is just a quick summary of what your data looks like, right? And so I won't ask you to find the median, or I won't ask you to find the quartiles or anything like that. I'll just ask you, give the 5-number summary of this data, right? And so then you know, okay, well, that means I have to sort my data. I have to find the median. I have to find the quartiles. And then the minimum and the maximum, they're just kind of easy money, right? So once you've sorted, you just have your minimum and your maximum. So I like to start there, okay? I'll just do this one. Stealing this example here. Copy. So I'm just using the full 11 data points. So from here, right, we have our minimum is 1. I like to lock these in right away. Our maximum, 16. Okay. And then you would, so you've already sorted your data, right? I'm assuming that. And then you boop, boop, boop your way in to find your
or say, hold on.
Hello? We found our median to be 7 for this example. Okay. And then your quartiles, your first quartile was...
Now please say or key in the 3 digits printed to the right of the signature panel on the back of your Scotia card.
If you're doing online
That
banking...
doesn't match my record.
Maybe
please say or key in the 3 digits printed to the right. Thanks. Your Student Banking Advantage Plan has a balance of $27.04. You can say, repeat that, or more details. Otherwise, how can I help you today?
Yes.
If you prefer to use your keypad, press 1. You can use your keypad from now on for self-service banking, such as obtaining a balance or recent transactions, or to pay a bill or transfer funds. Press 1. For online or mobile banking inquiries, press 2. Or for help from a representative at any time, press 0. Sure.
Please.
So I can direct your call to the right representative. Select the option that best matches your request. For your everyday banking needs related to your bank accounts or account access, press 1.
Shivam, maybe
Credit
you
card?
can...
Sorry, here are your options. For your everyday banking needs related to your bank accounts or account access, press 1. Credit cards, press 2. Loans or mortgages, press 3. Investments,
I know,
press
that's what
4.
I'm here.
Small business banking, press 5. Insurance, press 6. For anything else, press 7. To hear these options again, press the star key.
He's obviously
Okay,
not there.
please hold as I transfer your call to one of our representatives.
Okay. All right. Well, it
Your
seems like
call will
there's...
be recorded and could be
Yeah,
used for
oh.
quality and authentication purposes. Need to send or request money? Do it quickly and securely with Interact e-Transfer. Try it today at Scotia Online or the Scotiabank mobile app. Ask us if you'd like more details.
Okay. Like, how do I... Let's see if I can maybe, like... Okay. I'm the host with the most. Okay. That was the problem. I wasn't doing it from the host screen. Sorry, guys. That was very disruptive. Hopefully I didn't mute myself now in all that. But also, yeah, really funny. It's like growing pains, guys. So, that will probably happen as well. All right, so where were we? We were on the third quartile, which we decided was 9. Okay. So, just looking at your assignment 1, right? The first question is going kind of way back to the beginning, talking about, sampling and all that fun stuff. What types of variables do we have, right? I think we can kind of trudge through that. Question 2, though, right? The first 2 parts, I asked you to find the 5-number summary for each of those data sets. All right, so that's what I'm asking you to do. I'm asking you to just find the 5-number summary, which means find the median, find the quartiles, the minimum and the maximum, right? And just list them in that order. Okay. How about the next part? Does either group contain any outliers? Right? How are we supposed to know that? Okay. So I'm going to show you now how we find if there's any outliers. So what we said before, right? I'll just make a little note here. We're talking about outliers. Oh, what the? Got stuck on my own screen. Okay, so when we look at data, right? For example, this data set, this tiny data set that we have here, right? We could look at the litter of one baby, right? That's a small litter. We would expect to see something larger, right? And 16, I think, again, we're kind of like, whoa, that's huge, right? So we have this kind of intuition about what's extreme and what's maybe normal, right? Especially looking at all these other data points, right? We're kind of thinking, oh, one's a little, yeah, that's small. And 16, whoa, that's huge, right? And so we have this idea of what could be an outlier, right? But we need to have mathy ways of determining if we have an outlier, right? So we need to have some sort of threshold where we say anything smaller than this or larger than this will be considered an outlier, right? If all our data points are within those thresholds, then we don't have any outliers, right? And so to find outliers and to determine if there are any outliers, we use what's called the 1.5 IQR rule. Ugh, hard to say. Okay, so we need to be able to determine, if a data set has outliers, and so we use the 1.5 IQR rule to calculate thresholds, to calculate numerical, I'll say, thresholds. So what that means is that you're going to have some lower bound and some upper bound. And these are going to be values that we calculate. And anything outside of this will be an outlier. And anything within those thresholds, right, will not be considered outliers. So we'll just say not outliers. Okay. So we're going to have these values that we calculate, and then we just have a firm threshold saying anything smaller than this or larger than this, that's considered outliers. Okay. So to calculate the lower bound, I'm just going to tell you, we do Q1 minus 1.5 times the interquartile range. Okay. So that's the 1.5 IQR rule. Okay. So if we just scroll up to our list here, right, from Q1, so from that circled 5, we're going to move down 1.5 times 4 units, right? And anything smaller than that would be considered an outlier. Now the 1.5 is just completely arbitrary. You know, there's different people or different sectors use different values. You can use 2 times the interquartile range. You can use basically whatever you want. but 1.5 is kind of the established guideline. Okay. And so it just depends on how picky you want to be with your outliers. Okay. But we're going to use the 1.5 IQR rule. Here's a rude move that I made. I didn't put the 1.5 IQR rule on the formula sheet, right? So I do expect you to remember it, right? That the lower bound is the first quartile and then minus 1.5 times the interquartile range. Oops. Okay. So in our case, right, our Q1 was 5 minus 1.5 times 4. Right? And so I'll always use my calculator. Bedmass, right, we have to multiply 1.5 times 4 first. 1.5 times 4 is, so we have 5 minus 6. So in this data set, right, any value smaller than -1 would be considered an outlier. So in this data set, any value smaller than -1 would be considered an outlier. So I'm just gonna steal this list so we have it. You probably have it right in front of you, so may as well do it all. But for me, because I'm not seeing a lot of my screen, right, just repeat, right? And so what I like to do is I like to, once I find the lower bound, I like to kind of draw it in on this row of data. Right? So -1 would kind of go around there. If, for example, you calculated your lower bound and it was 2, right? Then the 2 would go between 1 and 5, right? And that just shows you that the 1 would be considered an outlier, right? That's just an example. That's not what's going on here. Right, so I'll undo it, right? But that's why it's good to just kind of write in your threshold, and then you can visualize and say, okay, well, there are no values less than -1, so there are no outliers on the lower end. Okay? So we have to say that, right? It's always your job to show me how much you know, right? And so I will make you write a lot, but it'll be structured, okay? So here's what I would expect to see. So since there are no values beyond the lower bound of -1, there are no outliers on the lower end. So for the lower bound, right, we went from Q1 and then we went down 1.5 times the interquartile range. To get this upper bound now, we're going to go from Q3, but we're going to add 1.5 times the interquartile range, right? Because we want to move up from Q3. Okay. So for the upper bound, it's going to be Q3 plus 1.5 times the interquartile range. So Q3 was 9 plus 1.5 times 4. I guess it's still 6. 9 plus 6, right, it's 15. And so now when we draw in this 15 boundary, right, it would be between 10 and 16 somewhere. So now we see that we do have an outlier on the upper end. Right? So I justify it. I say, since there is one value larger than the upper bound, of 15, there is one outlier on the upper end. So on your assignment, right, when I ask you, does either group contain any outliers, right, kind of seems innocent enough of a question, right? But that means that you're going to calculate the lower and the upper bound for each of those groups, right? And you're going to see if there's any outliers, and you need to justify it, right? So you need to say for each of the bounds, or if you want to compound them into one blurb, right? Since there are no values beyond the lower end and only one value beyond the upper end, there's one outlier in the upper end. You can say that too, right? But you have to talk about both ends and how your bounds compare to your data. Okay. So it's pretty fun once you do enough of them. Okay. All right. Questions so far? Cool. All right. So we can visualize the 5-number summary with a box plot. We're not going to talk too much about box plots, right? But we'll need to be able to recognize them at least. So we visualize a 5-number summary using a box plot. So a box plot is on, well, usually just the y-axis, right? So a little tick, 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 tick. Right? And then where we start the box plot in general, just a quick sketch is going to look something like this. Oops. Sorry, that's just one line. Okay. Just a quick sketch where the center line is the median. So that's where we're going to start when we draw it out. Okay. And the lower bar of the box, right, is going to be your Q1, and the upper bar is Q3. I guess I should have just made a nice sketch in my axes here. Let's do that. So I'm going to start with a box, because I'm not going to do a box plot for our data. This is just in general. So we start with a box, and in that box, you have a line in the center. So that line in the center is the median. The lower end of the box represents Q1. And the upper end of the box is Q3. Right? So the box represents the central 50% of your data. The central 50% of your data. And then the rest is just kind of on the end. So we draw them as a stick in the middle going down to a shorter bar to the minimum. Yeah. Same thing on the bar on the top. We have this bar going up and then a shorter bar at the top representing the maximum. These little guys, the bars that are coming out the ends, they're called whiskers. Oops. So these are called whiskers. That's fun. It's just a fun fact. Okay. If we wanted to draw a box plot with the outlier that we found, right? So in our data set here, we said that there's one outlier. And so our box plot would represent that by extending the bar to 10, right? The whisker to 10, and then just showing 16 as a star. Okay. So in our example, I'll just copy because I can't keep scrolling like this. Right. Oops. We can, I'm not going to say draw, we can sketch, just a quick sketch. We can sketch a box plot. So let's say each bar is moving up by 2, 2, 4. Oh, I'd need a way bigger graph. Let me try this little guy. Oh, I didn't make it big enough. Oh well. Just make sure it's long enough. 8, let's say, because we want to go to 16, right? So from 0 to 16, 2, 4, 6, 8, 10, 12, 14, 16. I'll just extend it one more. This isn't terribly important, right? I just want you to see it. Okay. So moving up by 2s, 4, 6, 8, 10, 14, 16. If, and I used to do this, but I don't really anymore. But it's good to see it anyways. Right, so our minimum was 1. So we're gonna draw our minimum bar at 1. I'll start with my median actually, because that's what I should do. So starting with the median at 7, the 7 would be somewhere around there between 6 and 8. And then our first quartile was at 5. And our third quartile was at 9. So you can connect your box up. Right? And then extend your lower whisker to 1 because there were no outliers on that end. Okay. And then for our top whisker, it would really only go till 10. Right? So we draw our top whisker at 10. And then we have this outlier at 16. So we indicate the outlier by just a star or a dot.
So you're going to star the max.
If it's an outlier.
Oh, okay.
So all the outliers we show as stars. So in the lab, when we look at box plots, right, it'll just generate this. And then, so now you know when you see a star or a dot outside the box plot, right, that's just showing you that you have outliers. Okay. Cool. Let's see here. So we're just quickly going to finish chapter 1. Don't worry, it won't take long. But any questions about that before we wrap things up here? So section 1.7 is on visualizing and summarizing categorical data. Right? We've only been talking about numerical data, right? But categorical data is kind of a little bit boring. Right? It's not boring, but there's not much to do with it, okay? Especially because usually people like to report things like pie charts or donut charts are for some reason really in right now. But I'm here to tell you, you shouldn't use those because they're no good, okay? So to visualize categorical data, okay, we only have one good option, and that's bar charts. Bar charts, or I'll call them bar graphs interchangeably. Charts and graphs are the same. Right? Some other options that we shouldn't use are the pie chart or even a donut chart. Clean this up. People love that donut chart right now. Okay, so categorical data, right, is where we have counts in each category, right? So categorical data we have counts in each category. Okay. And so a bar chart might look something like this, where we have males and females, let's say, and a bar to represent how many males and a bar to represent how many females. Okay. So this is a bar graph. Pie chart. Males, females, for example. Trying to show the same distribution, right? Categorical data still has a distribution. It's just a little bit boring, right? Males, females. So they can't follow a normal distribution or anything like that, right? And the famous donut chart is the same as a pie chart, just with a hole in it. Okay. But the reason that I'm going to tell you not to use the pie chart or the donut chart is because we can't detect small differences, right? So the only way that we can detect small differences in the categories is with the bar graph. Okay? So we use the bar graph because it is the easiest to detect small differences, right? Thinking of if you have a bar graph that looks kind of like this, right? Minute differences there, but it's still easy to spot. Whereas if you did a pie chart of that, it would look essentially like this, right? Something like that, right? So it's very hard to spot and detect those differences. Okay. One last thing before we go. When reporting on categorical data, we should be reporting the proportions. So when reporting on categorical data, we should use proportions instead of raw counts. Or just as a refresher, a proportion is the number in a category over n. Remember n, so recall, oops. Recall n is your sample size. Lowercase n. Any questions? So now you can do all of assignment 1. The first page, it says, suggest a sampling strategy for carrying out this, just anything you can come up with. Right? There's no wrong answer for part E of question 1. So just tell me what you think you should do. Okay. All right. Have a good weekend, I guess. See you on Monday. Thanks. End meeting. There we go.